Okay, so the idea is we often work now in multidisciplinary teams where architects are working together in teams with structural engineers and mechanical engineers. We have to design all the different systems of the building, and what we're starting to do is actually use the BIM models, building information models, as a way of really coordinating all that work. So we put the structural elements into a building model alongside the architectural elements and the HVAC and all the mechanical elements, and we really try to keep them all coordinated and see how they're going to interact with each other. So building models, actually I'll start with that. Are any of you familiar with Revit or any of the building information modeling tools? Have you played with that at all? A little bit, very little. Okay, the idea with the building modeling tools is that really we can go ahead and start to create really pretty realistic 3D models of what we're trying to construct and then use those really as the basis for visualizing, for creating the construction docs, or really even doing analysis and simulation on them. Because these models, they're not just there as graphical representations for producing the views, but they actually understand real things. They understand weights and loads and stresses and properties so that we can actually do things like structural analysis or start to think about things like, oh, for this space, how much air needs to flow into this space, and track that back to how big the air handler has to be to supply the HVAC system. So building information modeling has really kind of become the core of just really the whole way a lot of the design community is really communicating right now, that we do a lot of this through models and we use them to help us coordinate our work. Because if you've never been in an office and you've tried to do this with plans and sheets, it really gets to be very, very difficult to line up views and do the coordination between them and really kind of see how things are interacting. One of the hardest problems is 2D abstractions really remove a lot of the information that you might need, and the idea is if we can do that on a computer beforehand, that's going to put us in much better shape so that we solve problems before we get out to the field, where it gets to be really, really expensive to solve them. So let me do this. This is, I'm looking at a little bit of a structural model, but let me actually back up a track and instead look at the architectural model that's really behind this, so you sort of get a sense of how the whole process works. I'm going to go over to Revit Architecture, and again, just sort of another variation on the tool. This is an example of, I'd call this, this is a model that might have been done kind of at the preliminary design stage of a project. And the idea with the building information model is you're looking at something that at some level looks like floor plans at different levels, and we can kind of zoom in and take a look at any of the different elements in this model. The doors and the walls. And as we go through and look at the model, any of the different elements in the model has properties. So it's understood, it's not just two lines, it's understood to actually be a wall that has dimensions to it, has a length and area, things like that. But also has some,
May I ask a question?
Certainly.
This is 2012 version?
Yes.
Okay, the property box is usually on the left.
Exactly. Oh, actually, I'll tell you about that. And this is always this thing. You can go ahead and sort of organize it however you like. I am one of these people, I tend to like to see the properties, so I just pull that over to the right so I can see it exposed.
Yes, and the other thing is you were showing in each level the analytical, the framing. Usually it appears with level 1 analytical, level 2, and level 2 has analytical. Could you add these things?
Yes, yes. So
that's what I don't know how to do.
Yeah, well, we'll do that when we get over to structure, because that's, and remind me of that, because we'll do that in terms of, because what happens is there's these different plan views. Okay, but really, each of these different views just has properties to them. So in each of these different views, right now I'm looking at just an architectural floor plan. Actually, let me do it over, I'll do it over in structure because it'll make more sense over there. Over here I'm looking at, like an architectural view. Okay, and there's really not much architecture in this because I'm all, yes?
I have a question.
Yes, oh please.
It might be something that you can get into later.
Oh, no worries.
But a lot of us use Rhino for modeling form, and then a lot of times going from that to building is complicated.
Yes.
And I guess a lot of us know what Revit can do, but then taking that, taking the functionality of Rhino and the workflow from Rhino to Revit is sort of uncharted and rarely effective because you send something in from Rhino and it's mass, or and I know that there are ways of turning mass objects into building, but I guess how do we? What is an ideal way
Sure.
of
Well,
moving from Rhino
Sure. Okay. We'll take a look at that. And as in looking at that, I'll give you sort of some best practice. I won't say it's the ideal way, because I think that there really is some things that are a little bit uncharted or things to be developed to make that a little bit easier. Well, yeah, let's take a look at that, because I think that's really a context that's of interest to you. Oh no, actually, I do this all the time. I pop up and down. So don't feel bad. I'm always like down on my knees, jumping up and down, doing this thing. It kind of works. I don't know. Okay, so here's basically the deal. So, Ruma was asking about the whole idea that there's different types of models. For example, I have an architectural model. I'll say there's a framing model, or even an analytical model. And we can go through at each of the different levels and create different plans featuring different things. So, for example, if I wanted to go ahead and create another view, for example, let me just take that architectural view and I'll duplicate it. Create another one. And I'll rename it. So I'll call it level 1. I'll just give it a different name. Say OK. If I want to turn on the analytical model lines versus the architectural elements, whatever, there's this thing about controlling what's visible in the view. And all that's controlled under the View tab, where I can then say, oh, there's a choice up here called Visibility Graphics, and you can choose what it is you want to see, whether you want to see only the structural elements, whether you'd like to see the architectural elements too, or in the case of the analytical model, there's this choice here about whether or not to show analytical beams, braces, and things like that. And let's talk about what those two things are. There's what I'll call the real model categories. Those are the actual beams showing the 3D geometry, the actual columns showing the 3D, the walls, things like that. The analytical model is really, you can almost think of it as a line model, which is showing the analytical lines of each of the different elements and how they all connect together.
And you can enter loads to the structural loads.
Exactly. So you can choose really which ones you want to see. For example, if I want to see the analytical columns and beams and put on the braces in here, I can show them too. And what you'll see is actually happening here is now there's these little blue lines, or these blue dots. Those are the actual analytical column lines. And when you're seeing them overlaid right on top of the architectural column lines. But the same thing sort of works also in 3D views. Let me pop over there just so you sort of get the same sense. In this view, actually, let me change it to more of a wireframe. You'll see that there's actually two things going on there. I'm looking at the real model elements, but I'm also looking at the analytical elements. The analytical elements being those blues and the oranges and stuff like that. So,
are these features that are also in Revit architecture?
Actually, let's go back over there and kind of see. A lot of the stuff is available in Revit architecture, but let's kind of see if the analytical model is too, because that's actually a good question. Like, I know I can model columns and in fact, I can show you how to do that. Let's kind of switch over here. Let me just go to Visibility Graphics and sort of see if I can get those analytical categories here. Yep. Although there's nothing in there at this point, although if I think about it, it may be just because I don't have, let me try something here. In Revit architecture, I'll go ahead and start placing structural elements too. Actually, let's start with that. Revit architecture, Revit structure, Revit MEP. They're actually the same program underneath them all. They're just the same program with 3 different interfaces optimized for 3 different types of design. Okay, that's actually about to go away. In Revit 2013, all 3 of the tools sort of merged together into a single tool. So you have access to all the different tools, architectural, structural, it's all the same way.
What are they going to do? Are they going to eliminate the other 2 programs?
Yeah. Ultimately, those will be eliminated, but you have Revit now, and you can turn on architectural tab, structural tab, or even turn on the building systems tab.
I kind of like the fact that they have those separate components, separate programs that deal with specific issues.
Yeah. Well, what you can do is, if you like the separation, you can actually turn off the other issues. So as a structural engineer, you can turn off the tab, because it really just shows up through tabs. This has, in architecture, there's a structure tab. It's kind of funny, over in the structure side, if I go over to there, there's an architect tab. So, it's really, the features are always going to be there, but you can choose which ones you want to have available and which tools to kind of make your life simpler or have access to more. But going back over to architecture, okay, what I was going to do is just kind of create a real simple little structure here and just sort of see if they really are the whole notion of like that we can see the analytical lines. I'm going to go through, there's two types of columns, an architectural column, which will be more like a shell of a column, something which is really more just an architectural feature without actually be understood to have structural properties, or a structural column. I'll place that column on the first level. I'm just going to go ahead and drop something in here. Actually, that's a slanted column. Let me just do it as a vertical column. I'll just place some columns there. Okay, and then after I've gone through and placed those columns, let me go through and I'll put a beam in there. I'll put the beam in by using 3D snapping and say it's going to be at level 2.
We don't usually do that in, isn't it easier to do it in a particular level and then
Well, actually,
the 3D model getting generated?
it's actually, it's like yes or no, because you're really placing them in really whatever system, in whatever view makes the most sense. One of the hard things about placing beams in particular is this whole notion that when we look at plan views from an architect standpoint, we're often looking at a cut plane that's halfway through the floor and then looking down. So one thing that sort of confuses people is when you place beams, you're typically placing them above your head. So it's just a little bit confusing to people. So we could do that same exact thing that Reem was talking about. Let me go ahead and put a few more columns in here. Okay, and if I wanted to put them in here, if I go to the level 1 floor plan, you'll see, here they are all hanging out here. Here's the columns, but you're not actually seeing the beam right now. The problem is that beam is above my head. So what I can do instead is switch to the ceiling plan view, it's the ceiling view. Okay, and then you're saying, well, I still don't see it there. Okay, and the problem is, and this is sort of a funny thing about architecture versus structure, by default in the architectural version of the product, the views have the structural framing turned off. It's there, you can see it in 3D, you just can't sort of see it in this view. But again, turning on visibility graphics, you can kind of control that stuff, and I'll say, okay, as the architect, I still want to see the structural framing elements. Okay, there it'll be. Now, notice it's showing up here as a single line. Okay, often structural engineers like to look at their diagrams as single line views as opposed to showing the full 3D dimensions of things. So it keeps things a little bit simpler. You can keep it that way. If you want to see a little more detail, we can turn it up from a very coarse level view to more of a medium level view, which will then actually show the 3D bounds of what's going on. And then the question was, and let's go back to that whole issue of, here we are. Oh, actually, let me place another beam, and then we'll do this. Okay, so in terms of placing more beams, as Rima suggested, some people prefer to place beams more in the 2D views as opposed to the 3D views. When you place beams in a 2D view, I could load a tag, I just won't do it right now. Tagging would help us just in terms of identifying those things in plan views. Okay, in a 2D view, you have to be careful about what level you place it at, whether I'm going to place it at level 1 or place it at level 2. But now I can go through and do that same sort of snapping. Now, I'm not paying any attention to the size of these beams right now. That's kind of okay, because a way we often do this is we'll place beams, based on some that are available in here, and we probably have an intuitive notion about how big that beam may be based on our understanding of what the span is and our experience. Okay.
Well, the way, I'm sorry,
yes.
the way we do it, I mean, in a class where we calculate, in this class we don't calculate much, it's the first class. We draw the diagram, we use just approximate sizes,
yes.
And then we calculate
yes.
with a different program, and we come back and we change those sizes.
Exactly the same workflow. That's what I was going to suggest. Is that really?
You load the entire manual of seat construction into it.
Oh, exactly. So, for example, if you want to be more specific about these things, we can say, let's load a family, and we can go out there, and in the structure section, you can find framing, and there's wood framing, there's steel framing, concrete framing, different types of systems. If I choose steel, and I can choose what type of elements I want, whether it's just the wide flanges or all the different sections that I like, within there, you can open that.
Yeah,
and
we loaded open web joist into it.
Oh, that's a good one. Let's do that one too, because what I can do is, okay, these are just a bunch of W sizes, a lot of wide flange sizes, and you can choose the ones you want. I only have a 12 by 26. If I want to have, some things that are a little beefier, I can load in some more.
What if there's like a beam that, okay, maybe beams are probably not a good example for this question, but let's just say there's a beam that isn't. How do you make one?
Well, I can show you that too. Okay, we'll get to that one. So put that on my list, sort of like custom elements
Pull that
too.
in from that was from the family list.
I pulled what
There's
Load family.
you do load family. You go out to the library and pull in some more things. Okay, what happens is once you load it in, it'll show up in this list. And now that it's in this list, I can choose any of these things. If I suspect that one may be a little bit bigger, I can change it now just because I'm sort of trying to allow some space for it architecturally, okay, to make sure that my floor to floor is right. Notice actually when I do that, it actually changes its size over here because it understands the true dimensions. But ultimately, yeah, I'm just sort of guessing right now. What we'll do is we'll take this to an analysis program, and in the analysis program, we'll do the calculations and size this properly. And the nice thing is we can take the result from the analysis program and bring it back to the structural program, and it'll bring the elements with it. So it'll do the resizes. So, and then for analysis, there's really a whole range of different programs. I'll show you one that Autodesk has called Robot Structure today, but you could take it to RISA or ETABS, or there's really, there's a list of 20 different programs that you could take it to because they've worked out a standard format for how to transfer this information back and forth. Okay, so this has just been the 2D view. You sort of think we're only working in the 2D view, but actually, we've been creating the 3D view all along.
Yeah, that happens automatically. That's what's.
Yeah. So let me show you this. It's kind of a nice thing. If you like, you can tile your windows. Oh, I got too much tiling going on here. Let me close out some of these. I'll just have the 3D. Let me tile those two. So on this side over here, I have the plan view. On this side over here, I have the 3D view. So, and this is one of the principles of building information modeling, is that we don't really need, it doesn't really matter which side we put it in. If I go through and put a beam in, and in the 3D view, I tend to use 3D snapping to make sure I get to kind of points of interest. It'll show up in the 2D view too. So,
noticing that you're snapping to the center of the column,
yes.
but it's automatically resized. Do you have to snap to the center of the column?
You do, because, well, analytically, you want it to be to the center of the column. There's a whole separate discipline about how we detail that in terms of understanding really what the interface, between this column and that beam is going to be. Right now, just graphically, it does what it sort of stands it off. It holds it off, and later we can go back and sort of figure out, does that have some sort of a welded connection or some sort of haunch or something that's holding it up.
So if you were to resize that column, would it automatically resize the beam to go to the face of the column?
Oh, if we move the column, sure. Let's take a look at that.
It gives you warning notices sometimes when you're doing something you're not supposed to do.
Yeah. So let me go ahead and I can grab, in this case I'm grabbing the beam too. I think it would, yeah. But if I basically take that and I drag that on over, you just do all the resizing of that stuff.
So when you go to the center of the column, it understands that as the connection point.
Exactly.
You use that column always.
There's this thing about trying to connect things together. And yes, as opposed to just sort of putting it aside, to actually sort of put it to the center, says, hey, link it to this thing. That way it'll always kind of like move together. In fact, a good general principle for this, just as you get going, is a good hierarchy to think about is, have you talked about structural grids and setting up grids to sort of help lay out your columns? Okay. A really good thing to do is just start by laying out your grid. So I can say, let me put a grid.
That's how we usually do it. That's the first thing we do. Then you put them at the intersections.
Yeah.
Right?
So exactly.
It does it automatically. It places them all at the intersection.
Exactly. So I'm going to put some just grids in here. I'm going to put some grids in that direction, and I'll put some grids. The grids are starting at sort of what I'll call a funny number because of that other building. Actually, let me start with a new model. Maybe that'll be clear. Okay. Interestingly, I'm in Revit architecture. We're going to be placing all these structure elements. I can do this in Revit structure too. The only real difference is in Revit architecture, I can place the elements, but I can't put the loads on them and start the analysis. In Revit structure, I can put the loads on and start the analysis. Okay. But really, as an architect, you can still put all the structure elements in there. It's just you can't actually go to that next step of doing the analysis, at least in 2012. In 2013, again, that'll all get integrated. Okay, so, the general principle, if I was doing this as sort of a best practice, is I'd start by putting down some grids. Okay, the first grid comes down as grid number 1. The second grid comes down as grid number 2. And you can place the grids individually like this. That's kind of an okay way. Maybe it's 25 would be a better dimension. What I tend to do for placing grids, though, is my grids are often at sort of a very regular increment. So to make it a little bit easier to go through and place them, let's see if I can find that again. There's structure, there's grid. What I tend to do is I offset grids. And offsetting is kind of just a good technique from a lot of CAD tools and a lot of drafting tools. If you offset, let me say 25 feet, every time I just click on one, it will generate another one. So that's just kind of a quick way of getting a bunch that are regularly spaced. So we'll go that way. Let me go ahead and draw a grid in the other direction. Let me turn off the offset when I'm drawing for the first one. Now for the grid in the other direction, since the next one in line was 5 after 4, it started there. But really, more commonly, do you use like an ABC 1, 2, 3? Yeah, that's the way most people do it in industry. So I'll just say make that grid A. And then what will happen as I place the grids in the other direction, let's make these a little smaller, maybe 20 feet. And do the offset there. The next one will be, the next one will be C, the next one will be D. Okay, so real quickly, I can sort of create some grids, and that's a good starting point for this. So good thing is start with grids, okay? You can, if you want to, pin those grids down if you don't want them to slide around too much as you're moving other model elements, or leave them exposed. If you want to have the ability to move them, just kind of leave them there. If you want to pin them, just choose them, and there's this little push pin guy. Well, I want to let me pin them all. I'm going to think about why that's not going to let me do that in just a second, but it's not sure. Oh, now I'm looking at the unpin, not the pin. Per your point, I'm looking for a tool and I'm just not seeing it. No, they're not pinned by default. Let me grab them. I'm looking at the unpin and saying, why is that gray? It's because the pin's right underneath it. So I was just looking at the wrong tool. Okay, now they're pinned. What happens with a pinned element? A pinned element says, as you try to move it, either won't let you, it'll give you some sort of warning. And if I do want to move it again, then what I'll do is I'll unpin it, and I can move it, and then repin it again. Okay, so just, you don't have to pin things down. I tend to do that with grids just because as I'm moving walls and everything, I don't want to grab the grid and move it by accident. Usually once I put my grids down, they're pretty, relatively static. Okay. Once you go through and put your grids down, okay, great. Let's go through, put some columns on this. So you say column, structural column. And again, we can choose a steel column by default. We can load in a concrete column. Yes?
Is there a way to tell it to place columns at the grid intersection?
Yes.
There's a function at the top.
Exactly. So you either place them individually and kind of go dropping them on places, but really a much quicker way is this whole notion of at grids. Because at grids will then let you say, okay, let me grab this grid. I'm going to control click to grab this one. I'm going to grab all these, and every time I have an intersection, it's trying to put one there. Now, it's just suggesting those as locations. I'll have to actually finish to generate them. And then let's take a look. Now, actually, I should warn you, I just did something a little bit wrong or a little bit bad as a good standard practice. I got all those columns in there, and things are looking pretty good, but I betcha, since I wasn't paying any attention, actually, they're doing the right thing.
Property, the offset?
They are going to level 1 to level 2. That's actually fine. It's because I actually had the column tool set up the right way. Let me pop over to that column tool again and show you there's an option, though, that you have to watch out for. It's this notion over here as to whether your beams are going to go up to a height or down to a depth. And this just has to do, watch out for this. Yeah, in our architectural drawings, as we're looking at level 1, we tend to be drawing on level 1 and thinking about things that are coming up from the floor. Structural engineers sometimes look at it a little bit differently. They'll look at level 1 and they want to see exactly what's happening down. So, you have to watch out for this choice as to whether you're going up or whether you're going down. In this case, I'd already had it set up to height, so they went up. Okay. Yes?
Is it possible to have, well, let me rephrase that, I'm sure it is possible. How do you do, like, you have floors that are not just completely flat? What if you have a floor that goes up a couple feet or whatever?
Oh, sure. No, we can do that. Well, look, let me get to that in just a little bit. Okay, so hang on when we get to sort of putting a floor into this thing to talk about that. Okay, so we'll definitely get to there. So I got these things, they're hanging around, the columns are in there. The nice thing is since I placed them on grids, if I do something, for example, like take this grid and unpin it and move the grid, okay, the columns are going to move with it. Okay, and again, that's one of the nice things about having a model that's all kind of linked together. So we got the basic issue of kind of the grid, or the grids down now with the columns on them. Again, if I want to change anything, for example, if I know that this column wants to be bigger because it's in the center of the building or something like that, you'll start developing an intuition about the size of these things. You can start changing those or wait and do it as part of the analysis. Okay. I have my basic columns down here. What a lot of people will do next is start adding beams to the column and then joists to those. And there's really kind of a very logical progression to the whole thing, where you can, again, either do it in the 2D view or you can do it in the 3D view. You kind of get to choose which way, or both. If I do it in the 2D view, again, here's what to watch out for. As you place your beams, watch out what level they're going to come onto. I'm going to say level 2. And as I go clicking here to here, everything seems to be okay, but I get this little warning that says it's just not visible in this view. And it's trying to warn you, you are creating things, you just can't see them right now. And that's because it's above my head. Okay, again, if I would go to the 3D view, you'd see it. Okay, there it is. Or if I go to the ceiling plan view, I can see it there. Okay, or I could almost see it there. I don't quite see it there. The reason I'm not seeing it is because the structural framing is hidden by default. So what I'm going to do is go to View, Property, or View Visibility Graphics. Turn on the structural framing. Where'd it go? There it is. Okay, now I'll be able to see it. Maybe I'll bring it a little higher level of detail so you can see it there. Okay, so at this point, let me just kind of close some of these, say no to that. I got these two different views. I can kind of keep on adding things really in whichever view I want to. Let me go ahead and just add some more of these beams to it. Well, actually, let me add one more beam, and then I'll show you kind of, again, a shortcut for that even. So structure, let me go ahead and take a beam, and I can sort of snap it in 3D if I want to, here to here. Snap another one over here, here to here.
Can you have it just like snap all and just connect all the columns?
Yes. So let's go there. And where you do that is you go to Structure. Okay. Kind of like the columns have shortcuts. You know, beams tend to have shortcuts too. If you want to put a lot of beams all over your grid lines, you can do that. Let me come over here. I'll say beams. Beam basically has the choice. I'm trying to look where that is. Modify, place the beam. It's over in that tool. Okay, watch out for this. Actually, this is a very good point. It's all kind of like what Rima was asking a while ago. It's possible to sort of get off onto a different tab that doesn't have the tools you're looking for right now. Always look out up in the top if there's a green tab. The green tab means you're in the middle of doing something, and I kind of have some tools open waiting for you. And what happened there was I was looking for these beam placement tools, and I wasn't seeing them because somehow I'd clicked into the wrong thing, and I wasn't looking at them. And, you know, if you're looking for a tool that you think should be there, see if you have a green tab, because it's probably there. And this modifying placing the beams is there. The issue of placing them on grids is what you'd think it might be, to your question. I'll go ahead and I'll say on grids. What I can do is choose this grid, this grid, this grid, and this grid, and I'll choose those since I already put a bunch of them on the other side. Okay, and it'll basically put beams all along those grid lines. Oops, put them down on the floor. Okay, not very good there. Let me undo that. What I should do is actually pay attention and say, no, we're going to put them on level 2. Again, since I'm in the floor plan view, or the ceiling plan view, I need to sort of...
You could do something, keep them on the floor.
No worries.
Notice later.
Yep.
You can't undo. Can you just like click them all and tell them to move?
Actually, yes.
The offset, it's in the offset, right? You can
Well-
select
No,
them
the
offset.
form is just going to do
The
what it
property
is.
box.
No, there's two different ways to do it. So, yeah, what Rima's suggesting is there's this notion of a start and end level offset, so I could put in a numeric value there. Okay, and so I could put in here and say, you know, this should start 10 feet up higher than it is. Okay, and that's one way to do it. In fact, if I was doing a sloping beam, that's the way to do it. I can sort of slope it up there and do whatever I want to there. Now, but let me show you sort of something that's probably even a stronger way in the long run, in that, yeah, offsetting is good, but the problem is then, these beams will always think of themselves as being 10 feet off of level 1. Okay, I'd really like to have them think of themselves as being on level 2, so if my floor-to-floor height changes, they stay at level 2. So the way to do that is, I'm going to grab those beams. Okay, I'm just control clicking to grab a bunch of them. And as opposed to changing their offsets, I'm going to change what's called their host. The host being sort of, whatever it thinks they belong to. And it's right here. It's called picking a new work plane, or work plane in this case. So I'll choose that, and I can say that I want them to be on level 2 instead. Now, what is it doing here? That's not doing what I thought it would do, because that's definitely the operation, but that was a little strange in terms of what it's doing. Okay, let me try it with just a single one. Pick new. Oh. Hang on. Because that's almost like just moving it there. I'll get this in a second.
Well, it says work plane is level 1.
Yeah, I wanted him just to sort of jump on up. But hang on. I got the command right, but I'm like getting the wrong nuance in terms of what's going on. Let's go ahead and I'll do this. I want to grab a bunch of those beams, right? So actually I'm going to just go dragging through and grab a bunch. Pick up those two. Let me filter this so that I'm only looking at not the columns, but I'm looking at the beams. Okay, and move this to a different work plane. Use the tool when you select a work plane that is not parallel to the existing work plane.
If you
Go over here. It's still not doing it there. Oh, actually, I think it'll let me do it in this.
Drag them to another level?
No, dragging would work, but then it would still, I think, keep the same issue there. Okay, I got that. Let me try this now. Oh, it's going to let me do it here. Okay, I'm going to basically pick level 2. It's interesting. It's being very view specific about what's going on. Well, it's interesting. They're moving at the same time.
does it not know where to go on level 2?
Yeah, I'm just fumbling with this. The answer is yes, there is a way to do it. And I'm just sort of messing around, fumbling through the specific technique for doing it. Yeah, but there is, and it involves picking the new work plane, and I'm just drawing a blank right now in terms of the real specific thing we need to do there. But no, you're definitely right about there should be a way to do that, and there is. And I don't know why I'm just drawing a blank in terms of because I know it's this tool. I say F1.
The problem with just manually moving it is it still references it to that first level.
Well, yeah, exactly. And that's what we're trying to avoid is that we don't want it to reference it to level 1. We want it to reference it to level 2. And I think that being that, it might be because what I'm basically trying to do is change the host. Right there, change the work plane. And there it is, and I should be able to, but the question is, again, I'm not seeing what I want to see to do that.
Wait, but we created the beams as a function of the grid. So what if you move the grid up?
Now, grids are actually, they're, what is it? They're 3D. So now it won't be that. But again, let me go ahead and just get rid of these. I'll do it the right way, and we'll kind of keep on going. And then, what about like 2 hours from now, it's going to pop into my brain what it is I needed to do. And that's sadly that's the way the brain works. It's like there's a way to do that, and I just got to get it right. Okay. Back over here. That's going to bug me now. But let's keep going. Okay, we'll say put the beams in there. Let me go through, and again, I will put them on the grids. And I will again choose these grids. Oh, but before I do that, since I should learn from my mistakes, I will put them on level 2 instead. And now put them on grids.
I have a question.
Yes.
Some beams already exist between the two columns.
Exactly.
A beam on the entire sort of grid. Will it register as there being 2 beams, like sort of?
It'll say there's a duplicate right there.
It would warn you.
So watch.
Because they count the materials at the end, right? And
Exactly.
It can calculate costs.
Exactly.
So you don't want the double counting.
So in this case, if I say finish, it should warn me. It'll warn me at some point. What's that?
And then the one over to the left selected.
Ah, so it didn't actually go that far. Let's see what's going on here. Is there 2 here or not? Nope, there isn't 2 there. Okay, so I didn't have that guy. Oh, that's interesting. It only put it for the span of between the grids that I had actually selected, so it didn't actually go to that last one. Very good. Okay, so yeah, then to your point, if I said, okay, let's put them back on the grids, and I do that one, that one, that one, and this grid, and I do that one, it'll kind of warn me where there's some identical elements in there.
Well, can you tell it fix delete duplicate, like overkill?
When it does that, no, it's actually, I'm trying to think, well, can you go through, there's some little extensions that'll help you eliminate duplicates. Okay, but there's not kind of a default command for just doing that. So in general, it's better not to put the duplicates in, or I have to go ahead and find them. What I can do is, for any of these different things, I think it's under view, there's a place where you can basically look at the warnings and kind of see where things are, and then like, there it is, I think it's right down there. There are identical instances in the same place. In fact, even right there, you can sort of see where it is. And over here, I can show me where that is. Okay, there's 2 sitting right there as far as it's concerned. I can choose one of them over there and delete the checked one. Yeah, there's ways of trying to like get rid of excess things. So I think again, there's one over there. There's not one over there. But you gotta watch out for these duplicate guys that are hanging around. Okay, let me just finish putting the beams in, and then we'll go to the next step, which is typically to go through and put some sort of beam system in there. Oops, structure.
Yeah, the beam system is a nice option.
Exactly.
It does a lot of things quickly.
So I'll finish that out. Okay, so we put our beams in here. Now, one thing to kind of watch out for when you're placing beams in there, and this is sort of an issue of, it depends on the type of construction you're doing, and you've probably talked about this a little bit. You know, as you're going through and doing, if you're doing, for example, concrete construction, okay, often when we place our beams, we can say they're going right up to the floor level. Because what happens is, the way we'll do the detail, the concrete of the beam and the concrete of the floor can kind of intersect with each other, and we'll do the steel in such a way that it all kind of makes it work right in terms of the beam being integrated to the floor. But when you're doing concrete, often you can just say leave it right at the floor level and things are going to be good. Steel's a little bit different. When we do steel, what tends to happen is we'll put the floor in, and it'll be like a lightweight concrete deck, and there'll be some sort of like a ridged kind of pan underneath it that'll be supporting that concrete. And that whole assembly has a thickness of around 5 inches. So when we put in the beams for steel, yeah, yeah. Yeah, we don't want to, for the default one in here, it's 5 inches, but 7 inches would be for a thicker floor plate. Okay, so rather than just going ahead and even putting the beams in just at this height, right at the full floor level, what we can do, and this is sort of what Rima was suggesting, is this whole issue of going through and doing the offset. Let me show you how that would work. If I go through and grab all those beams, I'm just going to grab a bunch of them, and I'm going to filter to make sure I'm only grabbing the beams, not the columns. So I'm going to turn off the columns.
I also offset the columns by 2 feet, so when we do the splicing,
yes,
it's above the floor.
We can do that too. That's a very good thing to do also. So for all these selected, let me see if I actually got them still. I grab all those, and again, I'll filter them out, so I'm just getting the structural girders of the framing. Okay, I got basically a bunch of these like columns or beams selected now. If I'd like to offset them all, okay, it's still going to be relative to level 2. It's still off of level 2, but just a distance from that, because again, if level 2 moves, I'd like them to still move with level 2, just the same distance from level 2. What you can do is, right now they're currently justified to be at the top. I can say other, and put in an offset there like -5 inches. That'll work with a standard deck that's in Revit. But again, if you have a different deck, we'd offset them a different distance. We'll say apply. Okay. If you go on over there and take a look now, you'll actually see that they're slightly offset. They're down a little bit. Okay, and that's generally a good thing for what we want to have happen. Now, the difference between the Z level offset here and the start and the end level offset is really, is it going to go, or is it going to do this? Yeah, you get to sort of decide which is really what you have in mind. Are they going to move down together, or are you trying to actually create a slanted beam or something like that? Okay, so either way would work. I could put the same offset on both sides. Yes?
If you define the beams as being, you know, like going from the end of the column to the end of the column. If you were to add an offset, would that affect it? Or is it like, does the floor level govern where the beams go?
The beams are placed relative to, well, it starts with level 1 or 2, okay, and then with the offset. So, there's sort of a hierarchy to what it does. So, for example, just like, to your point, if I come over here and if I decide, we're partway through the construction and, someone tells us that, to really accommodate what we need in here, we have to actually have a 15-foot floor-to-floor level. Okay. What's going to happen is everything is defined relative to that level. So the columns got taller, the beams got taller, everything got taller relative to what it needs to be.
So if that was still on level 1 and you did that same function, it would have moved it.
Exactly, because 10 feet above level 1 isn't the same thing. Yeah, exactly. Exactly. That's why it's so, really, it's key to get everything hosted by the right, and get the hierarchy of what the dependencies are in the right order. Because if you get them right, everything's beautiful. If you don't, then you have weird things that jump around in funny ways. Okay, so we start with this. Rima was mentioning that we often also do something where we adjust the column heights, and this is true too. We'll take these columns, and maybe at the first floor level, we'll go through and say that, for the top of them, we don't actually want it to end right at level 2. What we'd like them to do is actually end, like 2 feet above level 2. And the nice thing is if they end up a little bit higher, it's a lot easier to kind of get to the bolting connection. It just puts things in the clear where you'd like them to be. So how we would do that is I'd filter, I get the columns, and I'll give them what's called a top offset. So don't stop at level 2, actually stop at 2 feet above level 2. Okay, and then they'll all jump up a little bit and do what they need to. Okay, so the idea is, and the good point to get about this is you want to model things as accurately as possible to actually how it's going to be built. Because what not to do, and a lot of people will start by doing this, they'll say, I just need something that's 100 feet tall, so they'll go ahead and put something in here, and they'll put the 100 feet in, and they'll do that, and it'll kind of look okay in the model. The problem is, though, later on, whoever's going to estimate using your model, whoever's going to try and build using your model, will have trouble because they'll have your parts. What's that? Yeah, so go through and whenever you can, try to model as best and as accurately you understand what the construction sequence is going to be.
Yeah, that's absolutely true.
Yeah, that way you make life easier for everyone because you got to remember what's happening in these integrated project teams is you aren't the only person using your model. There's other people who are downstream who are using it to do analysis, to do estimating, to do construction planning. You all got to work together on it. Okay, so beam systems, just so you see what that looks like. Beam systems are really, we'd probably call them joists more than anything. It's just really the big beams are girders and carrying other loads. The beam systems are those intermediate beams that we space to help just carry the floor load, because the floor can only span, so much. So in terms of those, and I think you've been doing a lot of the planning in terms of these, in the class. So for a beam system, here's how it works. A beam system has a layout rule. You can decide whether things are going to be a fixed distance, a maximum spacing, a clear spacing. We tend to do things as a fixed distance more often. You put things every 2 feet, every 3 feet, something like that. The other rules would let you say that, no, I want to have 5 beams between here and here, and whatever that spacing is, it can be whatever it is. But I'll stick with fixed distance because that's probably the most common thing. Whatever the spacing is going to be, your beams are going to be, if it's a simple wood frame structure, they could be, if it's just very lightweight joists, every 16 inches or every 24 inches. If it's steel, maybe it's every 3 or 4 feet, whatever it is that your intermediate joists are going to be. Okay. This notion of how they're spaced, that is, within the bay, if there's an uneven increment, do you break the distance on both sides, or do you bias it towards the start or bias it towards the end of the bay? But here's what you want to set over here that's important. It's the issue of what is that? What is it that we're actually going to be loading in here? So we could go ahead and put in some more of these wide flange sections, but chances are you won't be using the same size. You'll be using something a little bit lighter. So we could bring in like those open web joists. Those are actually a really good choice for putting between the different beams. And what that might look like is something like this. Let me go to Insert. I'm going to load a family. And let's go out to structural framing. And I'm going to go to the steel and go and grab some of those. And they have all sorts of different sizes, the cage joints. Yes?
What file format are those downloads?
These are all, it's called an RFA, so it's a Revit family
And
format.
they can only be created in Revit? I mean, for example, can they be created in Inventor?
Yes. Well, actually, well, there's a way to transfer them across.
Okay.
Okay, yes, we can make your Inventor part into a Revit family. Okay, so I'll grab this little K-joist that has little rods in it as opposed to angles as the web elements. Again, we'll have the choice of some different sizes. I can get some 14-inch ones with different weights to them. Maybe some 16-inch ones, some 18-inch ones. Again, load as many as you need. Don't load the entire catalog, because if you load the entire catalog, it just makes your project bigger than it needs to be. Even here it's warning us,
Slows down, right?
Exactly. For our purposes, I'm being sloppy, but like you'll really want to go ahead and only choose the ones that you want. And in fact, later on, we can even purge out the ones that we're not using to kind of...
Does that affect the performance of the software?
Yes.
It slows down.
Yeah, just the more you put in, the more it consumes memory.
Even if you're not actively using it?
Yeah, just the fact that it's because it's in our project, it'll get loaded in. And the funny thing is, even though you put 1,000 of them in there, the fact that you have one loaded in there is what really gets the big memory hit. And these things, if you think about defining it, it's kind of, there's a lot of little pieces to this thing. So let's go ahead and I'll choose one of those K-joists. I'll choose one of the, like maybe the 16 inches with a K4 every 4 feet. I'll say that's looking pretty good. Okay, we're ready to go through and start placing this thing. And I got to find where the tab is because it's sort of hiding on mine because of the screen. Okay, where's the bound? There's the tools. What I'm going to do is basically draw a boundary. And this is kind of a common thing. Oh, we're going to do this with floors, with roofs, with anything. There's some elements, like the columns we were able to put in as individual sticks, individual pieces of the beams. We sort of said it went from here to here. We drew a line and put it there.
Yeah, but there's a way you can do it by touching those side beams.
Oh, exactly. We're going to do that. We're going to do that. Yes, exactly.
It's easier than drawing the human.
Exactly. So we have to sort of say what the boundary is. And we could draw the boundary, and again, drawing is okay, but drawing is, we never like drawing because drawing is not as powerful as picking. If you pick, then it'll be understood that it's going to rest right on that beam. It's going to be right on the beam that you select, and that'll actually make it, have a nice parametric relationship where if the beam moves, it'll resize. Yes?
Is there text input? Like, is there somewhere where I can pick script?
There's not in kind of the Autolisp sense, or no, not at that. There are keyboard shortcuts, but yeah.
Python plugin, let's say, or
Well, actually, no. That's something there is starting to be. So there's a kind of an API to this and a way to kind of start scripting things to make them happen. So I'd say not in the default interface. Okay, but there are scripting interfaces to this. So yeah, yes, you can record things and start to create macros, or there's a whole command language, because really that's how it's all really done under the covers, that you can use to go ahead and program. So people are starting to create custom element or custom scripts to do very interesting things they want to do. Okay. But the easiest way to go through and place things is kind of, as Rima suggested, probably to go through and use this thing where we pick an existing beam, because if you pick the supports, the nice thing is if the supports move, the boundaries understand to move too. Now, I'll do one other thing before I do the picking. I'll say that for the elevation, I have to lower these that same 5 inches. So let me put that in there. Okay, now we're ready to do our picking. So what I can do, I can pick on that one, pick on this one, pick on this one, and pick on that one. So I've basically done a boundary of like one little cell. Now, if you were kind of sloppy, you could go ahead and pick the entire area. Okay. Then we'd have a problem though where some of them would overlap, or they could overlap, just kind of depends on the spacing. It's probably better to pick a bay at a time. We could even copy that bay around though, but pick a bay at a time and do it that way. This little thing, you might see right in there, there's a little
circle that shows up when I do this in plan.
Mm-hmm.
After I select beam system and select the distance,
Mm-hmm.
you select whether you want it uncentered or at the beginning or at the end.
Mm-hmm.
There's a circle that shows up, and I just touch the beams that are on the side, and it installs it.
I'm trying to think, and are you working in Revit Structure?
Yeah.
Okay, because it's a little different between the two. Let's try it over there too, so we can kind of see what the difference is. Because I know the tools look a little bit different. That's one of the things this is one of the tools that looks a little bit different. Let's look at that in a second. This one still, this issue here, this is where, it's basically the beam direction. You know, what it's doing is it's assuming that the first beam I selected is really the direction that I want the joist to run in. Okay, that's why it's showing me these two little paralines here. So the beams are going to go this way.
It also draws lines, dashed lines that are either, it doesn't place them, but it shows them.
Yeah.
If you want it this way or that way.
Yeah.
Depending on how you move that circle.
Well, let's go ahead and take a look at that
And then
too.
you just click, and if you like the vertical option, you click and it does it vertically. If you like the horizontal option, you click on the horizontal one and it does it horizontal.
Let's see if we can get that to happen in Revit Structure. I know in Revit Architecture it's not doing that, but let's see on both sides. So over here, you know, if I change the beam direction this way, that'll switch the beams to go, or the beam joist to go that way. If I do this side, it'll go that way. But when you finish, you basically get something like this. Now, to go ahead and experiment with this though and see what the difference is between structure and architecture, and really it's really more in how the tools present themselves. Let's go ahead, what I'm going to do is I'm just going to save this model out and I'm going to open it up in Revit Structure instead so we can sort of see some of the things that Rima's talking about.
They're a lot alike.
They're mostly alike, but there's a few specific things around the edges where, like, you know, I think for the beam system tool, that's one that's a little bit different. Where, let me just go ahead and save this. I'll go ahead and save this NGIT. Let me just go ahead and close this one up. Okay, let me go over to Revit Structure again, and we'll open it up in that tool, and we'll kind of see what the difference is. So I'll come over here, and I'll open in Revit Structure, and you'll see in a lot of ways it's really just the same product, but you're going to start seeing these differences around the edges. So
I just thought of this because I saw on 3D Max. Is there a way to go from 3D Max to this? No. Right.
not from 3D Max, not in that
to
direction.
go 3D Max to Rhino.
Even that would be a little strange in terms of, you know, what I say, generating the right pieces that you need to kind of actually kind of make meaningful information out of this. Like, it is strange. Yeah, we do that. We've done this thing where we go from eTabs of RISA and take it into here, because if you have a line model, you know, we can then make elements out of your lines.
Because I know there's like an Inventor Rhino plugin.
Yes.
And so it gets complicated going from 3D Max to Inventor through the plugins to Rhino. So.
Yeah, no, I'm not as familiar with that, so that I can't really say much about in terms of what's going on. You know, 3D Max I think of more as being a destination as opposed to being a starting point.
Right.
Yeah, but again, that's just the way I think about it. People who are good at 3D Max are much better at understanding how to do the modeling in it. I do mostly much rendering in it and visualization.
Yeah, that's what I use it for, like smoothing.
Okay, so let's go ahead and kind of take a look at the beam system over here. I can look at it in the ceiling plan like we were looking at it. I can look at it in the 3D view like we were looking at it. The nice thing about, you know, in Revit Structure, these things are actually understood to be a beam system. So I can select a beam system as a whole and start changing it around. This is harder to do in Revit Architecture. In Revit Architecture, I don't have the ability to kind of change these things as dynamically. I can open them and recreate, I can open the properties, but there's a much nicer interface over here. But you're saying, is it when you look in the level view?
Yes, level, and I click on the home icon, then select, let's say, beam system.
Okay.
That's how I do it. And then you select the layout rule at 4 feet.
Okay. So I got the 4.
You see what I mean? The lines are appearing already.
Oh, I see. No, exactly. It's doing a little what is it? It's preview of what's going on.
If you change the justification to beginning or end, it will just start measuring from the beginning or the end.
Fantastic. Now this is really very nice.
Yeah.
Even much better. So this could be a reason why you'd want to work in Revit Structure as opposed to Revit Architecture, because I think
Architecture doesn't do that, right?
exactly. Yeah. So this is an example of a tool that's built in. So it says automatic beam system, and it's really we don't have that. That's actually a very nice nuance to it.
Yeah, it's very easy.
I like it. That's a good reason to be working over here as opposed to the other one. So
It's nice that you can literally, you just save the same model and open back and forth.
Yeah.
So if you know, oh, okay, I'm gonna be doing structural systems, I can work over here, where it's
Mhm.
got a few extra little divots.
Mhm.
Yeah.
in fact, this will be one of the things that'll be nice. Yeah, this is one of the reasons why it's because of that all these things are being unified into a single project. Because the idea was the fact that you had to kind of open and change and stuff like that, even that got to be clunky after a while. So in the new version, you'll be able to all the tools will be available with the right kind of.
So you triple the price of it, or?
No, it didn't. Actually, they sell it all as a suite now. So really, the way it works now is that all of Revit, 3ds Max, T-Spline's going to be there too.
Yeah.
Yeah. Yeah, that's all available everywhere. Well, the students still get everything for free. Yeah. So if for any of the software,
Download it for free. Use it for 3 years
You
with
needed
activation.
.edu.
I gave you that website, right?
yeah, if you just go to students.autodesk.com,
I give it to you. You have to create an account.
Everything was like 1 or 2 exceptions, I think.
yes. Although they're getting better. It's one of our things is to kind of get the commercial products to show up in the educational site too. But just about everything's out there now.
The activation used to be a nightmare, and we simplified it.
Yes.
Well, because you get 2 different accounts. The Autodesk Education
Yeah,
account is
it
different
used
from
to
the
be.
actual registration.
Well, yeah, it's interesting.
Now
One of
it's
them is just
doing
you're
it with one
registered with
account.
Autodesk.
Exactly. There's 2 different things kind of floating around there. They've tried to unify that, and even the unification process kind of broke a lot of things along the way. But if you start out from scratch now, you're better now.
It's how I have
They used to have a different website, register.
Yes. Well, actually, that one's
They don't have it anymore. Now it's the educational community. It's one account.
yes.
And when you just click activate, it does it.
Exactly. It's better if we can get it all to work that way. Just sort of be exactly like that. So let's go ahead and we'll finish this out just a little bit in terms of we're doing our beam systems. That's kind of good there. Oh, hang on. I'm in the middle of defining another one here still. What I'm going to do is just going to create a couple more. Continue there. We'll go to this thing. Where am I now? I wanted to go through and pick some boundaries. Actually, let me go back to the auto beam system. I'm sort of in a confused state right now. We're in Revit structure. Let's go to the beam systems. We'll do the auto beam system because that's kind of a nice way of doing it. I'll put one over here. I'll put one over there. In fact, this is so easy you probably don't even need to do the copying. But what I was going to show you is that if you do want to go through and copy, you can do something like this. I can take something and grab those.
Copy to clipboard and then paste.
Well, first I'm just going to copy it around in here. So I'll go through and just do a copy on the same level. And I'll do like this.
We do one floor and copy them to the.
Oh, exactly.
Training for one floor and copy it to the other levels.
Exactly. Actually, that wasn't very smart because my boundaries are a little bit different because I had changed those. Okay, but let's go. We'll go back in and do that again. So again, automatic beam system. I'll put one over here. I'll put one over there. Okay, now finally, let me do this. I'll grab those. Let me just grab those 2 beam systems. That's interesting. It didn't grab the systems. Tab. Okay. Copy. Okay, finally, good. And we'll do another copy. And then we'll finish this out doing what Rima suggested, which is the issue of if you can go through and model a single floor. See if I got that right. Okay, if I've modeled that single floor and things are looking pretty good, let me go back to that 3D view. Okay. You put all that work into modeling that one. You'd like to go ahead and be able to use it on your other floors too. So let's go ahead and show you how you do that. Currently I only have 2 floors, so I don't got a lot going on here. But what I can do is add some more floor levels. For example, let me go ahead. I'm going to use that offsetting again, just because I like to offset to make things easy to generate, where I'll say if 15 feet is my floor to floor level, let me make a 3rd floor and a 4th floor and a 5th floor. Okay. So once I have those set up, what I can do is either in 3D or in 2D or whatever that makes the most sense to you. Go ahead and grab all those. I can filter out things I don't want if I don't want to grab everything, but I actually am going to grab all those things. I'm going to copy it to the clipboard. And when you copy things to the clipboard, you have this notion of not only being able to paste, but paste them to specific levels. And that buys you a lot of power. So I can say align it to a specific level. And I'm going to go put it on 3, 4, and 5. Let's see, this is, again, one of those things that sometimes is a little confusing.
So what happens to those little offsettings?
We're going to have to go back and fix those, because the first level columns didn't have the offset at the bottom. The level 2, 3, and 4 columns will need that offset at the bottom to match. So what we need to do is kind of in that same...
I think it copies them with the offsets.
Yeah, but
Yeah.
your floors aren't 15.
So what's happening is this has the offset here. This one over there, though, you see there's an overlap. So what I have to do, and it's just because the first level columns are a little different than the other ones, is I'll grab all these ones up here. Okay, again, let me just filter out so I'm only getting the columns. Exactly. So we'll give them a base offset that's 2 feet to match the top offset. Even at the roof, we might want to take off that top offset. Okay, is it regenerating? Looks like it's still working. It's still flashing around under there. Something's trying to tell me a message, but I can't see
Yeah,
it.
for that top offset on the roof, we could just say, in the property box, extend to make that offset 0 and extend it just to the
Yeah.
roof level.
So let me just get the columns. And for these, the top offset will be to 0.
0.
Okay. And now, we have a pretty good looking structure. Okay, again, it should be pretty good looking in terms of, let me flip over to 3D. Let's get a little test and see how robust this is to kind of make sure it is still working. Remember when we got started with the whole thing, there was the issue of, how well it's going to respond to the grids and things like that. So if we find out that the building has to be a little bit bigger, that's interesting. They didn't move that time. I'm a little curious about that. Let's see if these ones are. That could be, again, something that's a little bit different when I brought it over from architecture to structure. It's thinking. That's usually a good sign. Or a very bad sign.
Extend the grid lines?
So when I move those grid lines over there, I did that over on that side. That was good. Let's go back to 3D. So it looks like it did a good job of moving those things around and moving the beams, and the beam systems have adjusted. That's looking good. For that end one, though, looks like it somehow got severed in terms of the relationship between the columns and that grid. Not to worry. Let me go ahead and just grab them, too. And just
What if you move it the other way?
move it in?
Yeah.
I think if it's independent, let's check it out. It's not an extension as much as I think the two things have just become disassociated. Okay. Actually, let me show you how you reassociate things if you want. That got an affirmative vote. It's a modify thing, where what I want to do is I want to do an align, and what I want to align, see, this to this. So I really want to say, bring you to me. Okay, so what I want to do is choose that, and then I want to see if I can get to the middle of that thing. It's hard to see what's going on there. Arg. I'm trying to see if I can select the center line.
The first 4 columns you made were independent, right? You just placed them down.
I thought, did I put them on the grids or not? I don't remember, actually, at this point.
If they're moved off of the grid lines, it shouldn't matter, right? I mean, they...
Oh no, the grid lines are really just sort of an independent thing. So here I am. There we go.
You told it to do it at the intersections, but the first line wasn't actually intersecting.
Let's, yeah.
Line number 1 was not actually intersecting.
Oh, is that it? So it was actually hanging off the end?
So that's what I was asking, like, are the grid lines infinite, so to speak, or are they?
Oh, actually, no, they are. Yeah, that actually, although from the purpose of the intersection, no, you may be very right there that maybe it isn't, what do I say? It's not generating. The grid lines, well, what? They're theoretically infinite, but you can give them a bound too. So I think if the intersection was outside the bound of what they're currently defined to be, it wasn't doing it. What I'm doing here is I'm basically just reassociating those columns with the grid.
Use the align tool.
Yeah, and then lock things into place. And let's see how well this did. Okay, so they're all there. That's interesting. Oh, it's interesting because it's not getting all the ones up there yet.
Copy them.
Yes. So, and a copy is sort of considered like a broken link in terms of what's going on. So we would have to do the same thing for the upper levels, or it's
Is there a way to make the grid work? Would you have to copy the grid? I mean, is there a way to make it so that you have like 3 different grids? Maybe?
Yes. No, you could have different grids at different levels.
You know, the other 2 are mimic what the first one does.
Well, what would I say? You can. Yes. No, there are ways. It's kind of an interesting question. So I don't want to go too far down it in terms of if it's a what would I say? Yeah. Yeah. Yes, you can have different grids because if you think about a tall tower, you might have one grid in the lower 5 floors, which are the garage, and a different grid in the upper floors, which are the hotel or something like that. So you can do stuff like that. In terms of whether they're linked, I think the grid elements tend to be fairly independent, but we could set up constraints between them. So if one grid moves, the other grid moves too.
Yeah, I would
But
like
it's sort of
to
subtle.
know how you can do a different grid on a different floor.
Ah,
Link grids together.
yeah. Well, really,
But really, what are the constraints that you can set up, or how
Well,
do you set them up?
let's take a look at it. It's really, let me go here. Let me find the grids over here. In fact, well, even there they are. Here's the problem right now. Grids are understood to be a 3D element. So what happens is we are on like level 1 and level 2 in terms of what's going on. So I only have level 1 and level 2. The grids are still showing there. Okay, so far so good. Let me go over to views. I'm going to create a new view for level 3 and then one for level 4. So we actually have a plan view to accompany those two. Right now I don't. So I'll say structural plan. Oh, actually, probably those are the floor plans for those. Let me go. I actually have them there. You'll see, though, there are no grids on these levels, on level 3 and level 4. And the reason is, if I come over here, the grids are currently only extending up through, like level 1 and level 2. Exactly. So if I want the grid to apply to this level 2, also, I'll pull it on up. Okay, those are all sort of interconnected. I can unlock them from each other, but that's why they're all sort of moving together. So now I should see all those grids on all the levels. Okay, now,
The 3D model.
no, the 3D model's all, well, since the copy sort of is a weak link, yeah, that wouldn't have actually.
It won't fix it because you can send the grid.
Yeah, the deal is, yeah, copy and paste is like it doesn't sort of carry all the same relationships. As though if the column had extended all the way up, yeah, I could have think about another way to do that. If I had placed the columns manually at level 3 and 4 on the grid, then everything would have moved.
So rule of thumb, be careful with your copying.
Yeah,
Or try to avoid all of that.
it's one of those holes that'll get you into. Because I guess copy and paste doesn't carry all the constraints. Yeah, it carries the location, but not the constraint. That might be the easiest way to think about that. Okay, now if I wanted to have a subgrid, for example, if I go back over here to the elevation and I said that, hey, I wanted to have a grid that only applied on levels 3 and 4, but didn't apply on level 1 and 2. Let me go to the grids, and I'll just have something over here like this. Oops, that's level. Hang on, where'd my grids go?
So you said there's a hierarchy to like how things, interact. So I guess would it be possible to define like connections, like butt plates, let's say, for columns. If I were to say, on each floor there's this connection between columns, could I then draw columns for the connections? Like, can the connections come before, and therefore like.
No, it's a good question. In the way I've always worked with it, you sort of you start with like the columns, and then you sort of build the connections on top of them, stuff like that. So I don't know of a way to do it the other way. Because I think there is sort of a hierarchy of that the connection then belongs to the column. So, but not 100% certain on that. Okay, here's the idea of we got this intermediate grid right there, 3, 3, 5, and it should only be showing up on levels like 4 and 5 right now. So if I go to level 4, okay, there's that grid, kind of a little odd. If I go to level 5, that grid is appearing, but if I go to level 3, that grid doesn't appear. Okay, and the way to control that is same thing over here. If I want to, it's just all a matter of just like pushing and pulling here. Let me take grid 3, for example. Let me get grid 3. I can't tell. I'm trying to select it, but oh, actually I do it down there. There's grid 3. If I unlock the top of it from the other sides, then I can go through and I thought I unlocked you. Oh, it's pinned. Doesn't like that either. So now grid 3 will only apply to the lower floors. So up on level 4 and 5, 3 isn't there anymore, but 3.5 is there. So that's how you can kind of control grids at that level. Okay, so you got sort of the basics in terms of putting a structure together. Let me go through just to put a little foundation work underneath it. If you want to go through and put in slab foundations for the entire slab, that'll be like very much like a floor, but it'll sort of be understood to have the structural properties. Wall foundations would be like a footing or something that's going to go under an entire strip of wall where we choose a profile and kind of draw like a line, and it'll put it along that profile. Isolated footings are the ones, let's go ahead and find one. It says they aren't even loaded right now. We'll go to foundations. They got some rectangular footings, some pile caps. They have all sorts of different ones in here. Different sort of shapes. I'm just going to go for a big old rectangular footing. We're going to get a pile cap. Okay. And what I can do now is I can go through and place those manually, but even a better way to do that is if you say at columns, and I'll place them at level 1. I can choose that column, that column, that column, and that column, and kind of very quickly start generating the foundation system. Again, the advantage of doing something like that is that they're located where the columns are. If the column moves, then the footing's going to move with it. Okay, so again, you're getting that sort of a hierarchy of things, kind of moving between different stuff. Does that make sense? Beauty. Okay, so that's kind of really the essence of a lot of the structural modeling in terms of what's going on. You know, most systems sort of work out in this sort of beam system, floor plates, that kind of system. You know, we can go ahead and put in like diagonal bracing, put in shear walls, things like that that are ultimately part of the system too.
Bracing, there's an option of brace over there.
Yes. Do you want to see brace? Brace looks like this. Braces are just really, diagonal elements. We'll use like more a wide flange, or actually, let me load in a piece of tube steel. That would probably be more common for a brace. Let me bring in structural. Oh, an angle would be good. Framing. Let's see what we got here. Like a nice L angle, something like that. And I'll just choose a size. Again, that may not be a very good size, but it'll get us started. Okay. For the bracing now, all we need to do is, and what I tend to do is, okay, let's draw it. Let me say 3D snapping. That always is a little bit easier for me. I'll snap from here. I could go diagonally all the way across and get to the point of the intersection right there. What I tend to do, this is always a little hard for me to get, is to find the midpoint.
So, is there a snap to midpoint?
There is a snap to midpoint, and let me see if I can find it for you. And I'll show you where you can turn on the snaps or not. In fact, under Manage, Snaps, midpoint is like SM in terms of trying that, but yes, you can turn it on or not, and what's going on. So let's see if I can actually make that happen by just typing the SM. No, I'm not very good about doing that in terms of doing the keyboard commands halfway through. I think it's right there at the top. Okay, that again is creating sort of what looks like an ugly connection in there. We're going to have to go through and do a little cleaning it up. See if I can find that same point. Where was it?
Where is it intersecting?
You want it to be right where it's intersecting. SM again. I'm not very good about doing snapping on these midpoints. I'll warn you about that. That's at least on the line. Oh, there it is. I saw it right there. Ah. Well, that's not very good looking. Oh, it put it in the midpoint of that thing. Let's
mirror that.
I think that would actually probably be a pretty clever strategy, wouldn't it? Which would be, okay, if we come in here and we look at like the ceiling plan, here it is. And since that thing's in the middle right now, yeah, for example, I could just go ahead and mirror and see if I can pick that one. Okay, and now it's mirrored across. So whatever seems to work out. So you can go ahead and kind of put in bracing like that. Yeah, bracing is just really just these diagonal elements that will be then understood as being a structural brace. If you want to go through and, what is it? Yeah, shear walls are another way to approach this. If you want,
show us maybe how to clean that up to make it a little bit, or is that a...
Let's see if we can. Again, I don't do this very much, so let's see if we can. And I think it's probably going to be this whole thing of coping. And let's see. That's for beams and columns. I'm not trying to be able to get you to clean that up nicely the way we want to here.
Is there like an actual
Well,
piece of something?
You just drag that top up.
well, this thing over here, actually, that's going to actually move it, I think, right? Yep. Hang on there. In terms of just cleaning it up graphically, there's this whole issue of let me see if I can make this happen. I'll say hold that back like a foot or something like that. Okay, so it still has the same analytical model. It's doing everything. I'm just actually sort of backing that off so that it is 1'6" or whatever like that. Oops, not 16 foot. Didn't go very far.
So what is that end attachment thing?
Down here?
Yeah, it says start attachment, end attachment.
That's just really, what it's thought to sort of attach itself to. Down at level 1, distance or a ratio. Don't know kind of the subtlety of the distinction between those two. Okay, so you can get a little bit of like a graphical, like a kind of cleanup in here. But really, when you want to kind of really play around with this stuff, let me kind of show you where that is. Let's go ahead and, I will take, for example, I'll do one that I'll know work pretty nicely. This column and that beam, for example. Okay, got them hanging around. They're looking pretty good in terms of what's going on. There are extensions to Revit structure that will help you clean up those things, including a steel connection sort of extension. So if that's not looking exactly like what you have in mind, we tend not to do this to all of our different details or all our different connections, but when you want to go through and start detailing out one, you can do something like a beam to column connection. It loads in, it's a little piece of Autodesk structural detailing to make this happen. And you can choose.
What is the extension?
You have to download them separately?
Yes.
The plugins.
Yeah, they're plugins. So it's almost like things that were created with the API,
Okay.
with all the scripting. And you can download them from, again, the student community. They show up as a separate piece, but they're available there, although I think a lot of these are actually built into the product in the 2013 release. You choose some sort of connection and really what you want the bracketing to look like, and are there stiffeners at the points of connection, all that sort of stuff. And when you've chosen all those settings, it'll go through and kind of go back and put in like all the details. Yeah. So, for people who have to do structural detailing, that's actually pretty nice. So you can go back and kind of clean up the individual things, and then, then you'll have accurate details for, the drafting and the beginning of the structural fabrication.
Is there any way to-
Extension, it's called the steel connection?
Yeah. So what you got to do for this one is you got to like go here to here, and it's under extensions. It's called steel connections, and then it's beam to column connection. Okay, really though, what it's doing is it's using a little bit of the Autodesk CAD's structural detailing to kind of make that happen. Okay, and again, you choose what kind of connection. Let's put a bolted connection in there instead on this other one and see how that looks. Okay, so
Modeling extension. Actually, what are modeling analysis?
oh sure, let's take a look at some of those. These are things that are all meant to extend it a little bit. Lots of groovy things. Wood frame walls. If you're doing a little wood frame structure, it'll go through and put the studs, the headers, the plates into the wall. It'll basically add a lot of structural framing elements to a wall for you based on the geometry of the wall. So you can do a lot of wood frame. That at least won't do it for ceilings and floors and things like that, but it will go through and do walls and kind of actually frame around the openings for you.
Excel based, like you can type.
I think that's going to be all coordinates, yeah, being able to type them in and do something like that. Never played with that one, so I don't know the
It's
details.
probably just like Inventor, then, like with the Excel spreadsheet.
Yep,
Okay.
yes.
Are you able to filter out, like, you made a column to beam connection, and you have to do that individually every time, or can you filter that out and like have them work together the same way you did with like the footings? The footings and the columns are connected?
Oh, that's actually a very good question. I would suspect that they're connected, but I don't know that 100%. Let's go ahead and take a look. So basically the idea is, if we go back over to level 1, for example, on the end of the building there, your question is, what happens if this thing moves? Well, besides it'll do something strange to the beam, that other beam. We'll see if this actually works. Doing a little regenerating. Exactly. Thank you. Okay, let's see what actually happened there in 3D. I don't know. So, oh look, it moved the connection, it dragged the beam with it. But no, it looks like now that is attached to that column beam connection. I think it'll probably persist as long as we kind of keep the beam and everything in there. Things that I think it'll probably break it, and again, we'll see if it does or not. I suspect if I go ahead and start moving that around too much, white
How do you
flag.
connect that column to, I guess, if you actually were to make a column-to-column connection, I guess that column also move with the first floor beam column with it?
Don't know. That's actually, again, sort of a good question. I think they're not going to because it was a copy and paste. What I should do is actually, if I do the align and the lock.
So if you copied and pasted connections.
Wait, but if you align and log,
Yeah.
then they're all going to move together.
Yeah.
Not because they're connected, but because of that.
Oh, no, exactly.
Okay.
Yeah. So, yeah, so the answer is, yeah, honestly, I don't know in terms of like which way.
Individually do each one instead of copy and paste.
Well, that's kind of a good question too, in terms of what can I actually do with this thing? Because it looks like it's there. So the question is, yeah, can I copy that thing? It's almost interesting about what a good reference point is.
So is there a way to like modify, you know, the parametric relationship between two things?
In what
Like,
sense?
For
Go ahead.
example, that connection.
Okay.
That connection is defined, I mean, is it defined as being, you know, at that intersection, or is it just an object that is being placed at a certain point?
It's, as far as I know, it'll be getting its point based on the actual physical intersection.
Okay.
Okay, so, and I think we demonstrated that just by when it moved, that connection
So,
with
yeah,
it.
would there be a way to edit how that, I mean, like, if we were to open up, like, the family editor
Mhm.
thing,
Mhm.
how do you tell it to exist at an intersection?
Independent of the object?
No,
Oh, right.
no. I mean, like, for example, if we were to open up, like, I mean, what is that thing? It's a family, right? It's a block object. That.
Yes,
So if we were to open up, like,
Sure.
the editor for that,
sure. Let's edit it.
what is it, like, how does it know, like, orientation and, like, where to be?
Well, actually, okay, we're on to something interesting in terms of how this is. This is real, okay, so it looks like what it's done is it's created a family for us made of all these kind of custom plates and bolts and things like that. This is it wall hosted or floor hosted? It's somehow hosted on the face of something. Okay, you know, and this being the element, which is the sort of placement face. So once we have this, you know, let me even kind of turn on the dimensions. Yeah, in this case, it's the column face. That's what it's kind of using for that. So let me go ahead and do this thing. Try and understand a little bit. So that's the reference level. So at this point, I think you can go ahead and, you know, redefine. Yeah, I could redefine the family to say that you are now 2 feet off the face. So I guess what it is it's defining a family relative to a placement face. So if you go out and edit this, the family, you could even go back in here and change, all it's really done is auto-generated a lot of elements for you. If you really wanted to have a more detailed control over this connection and kind of change it around, we could do that. But then, kind of to your point, it's interesting. I couldn't copy and paste it because it was stuck to this face. Okay, but since it's a family, okay, that actually gives me some hope that if we come back over here, which one? Let me go back to my 3D view. And I'll rotate that around a little bit. Since it is a family,
We don't have another one.
yeah, I just copied and pasted one up there because it was just sort of a family that way. So where is this thing kind of coming? Is it structural connection? It's probably that one. See, I should be able to kind of like just start attaching it to other ones.
Oh, okay.
Okay, but not so much as a copy and paste as much as a, yeah, it's a part.
Well, yeah, because it automatically knows how to and stuff.
Exactly. So that's actually not too bad then, because what it's doing is, I guess it's creating all the connection pieces and the bolts and stuff like that, and it's basically wrapping itself around the beam.
And then it knows that it's attaching itself to the column.
Yes, because it's hosted by that
Yeah,
column.
yeah.
Okay, cool.
It's just as easy as copying.
Yeah.
The order of
Should we take a little break?
Yes.
Oh, sure, please. Let's go ahead, and actually what'll happen is, yeah, let's take a little break for 5 or something like that. Come on back.
Look at Vasari.
We will do that. We'll do that. We'll spend the last half hour or so looking.
Analysis?
Sure.
Doesn't Ecotech do it?
Well,
Wait, Vasari is also Autodesk?
It's,
yes,
Really?
yeah,
so
You gotta go to Autodesk Labs.
yeah. So, and then it's good for energy and wind. Let's go ahead and we'll spend like the last half hour doing that. I have to, around 11:30, I'm gonna go meet with the student experts, but let's spend like our last half hour on Vasari and kind of do some of that. And you'll have a little time to finish up with students.
This is great, thank you.
Oh, you're welcome. Okay, let's go ahead and get ourselves back together. And what we thought might be interesting to do is actually shift gears a little bit and actually show, oh, it's kind of a different type of program. We're going to look at something called Project Vasari, which is sort of an example of, this is really more, it's more about conceptual energy analysis and wind analysis and sustainability and stuff like that. But it kind of illustrates kind of a principle of what we're doing with a lot of the design work now, where even at a very early conceptual stage, we can start to understand, what either the structural impact, or actually we have tools for starting to understand the structure at that level, but we can start understanding a lot of the different analysis things long before you start putting all those individual columns and beams and things in there. Because what you like to do is sort of really understand and have informed design decisions right up front before you make a big commitment to really doing all the detailing and like putting all that stuff in there. So Vasari is one of these tools that's out in the labs right now, and it's again one of the freebies that's out there. And what Vasari is really good for is if you just have some basic ideas about a site and a location and you want to start to understand what the energy impacts of some different decisions might be, you can go through and like just analyze and sort of take a look at that pretty quickly in Vasari. And let me do this just so that I am in the system, because it's sort of based on a web-based service. I'm going to log into your system and see if I can remember how to do this. And then let me see if my password's still working. Okay, looks like we're good. Excellent. So here's the idea. Early on, like we can also start to often describe our structures just in sort of very general terms as masses, just kind of things that have sort of overall forms to them, and we can start working with them that way. So the story works like this. For any sorts of energy analysis, whether we're thinking about the temperature and the energy impacts or the wind or any sort of sustainability, you like to go ahead and actually have an accurate location. So it's important for understanding what the local climate's like, the latitude and longitude, all those things. We can go ahead and just go through and use the Internet Mapping Service. This is all working through Google, and we can bring ourselves to Newark. Okay, and locate ourselves somewhere within here. Okay, we can choose a weather station. We can zoom on in and kind of choose a specific location, wherever it is that you want to be. But I can sort of move myself. Actually, that's right by Rutgers, so we're pretty close. Okay, and say that we want to use this weather station, which is pretty close to here. That'll give us pretty accurate, sunlighting and like energy analysis information from here. Great. We can also, if we want to, go through and import a site image. This must be somewhere close to the campus. Help me find out where we are. Does any of this look familiar?
That orange building.
That one right there?
No, that was the field. That was the field. You're right on it.
So where are we?
Go to the right, a little more.
Go to this.
A little more. Move that building. Just move the mouse to the right. Move the mouse to the. No, just the mouse cursor to the right.
In there? How about I'll go ahead and put ourselves. Oh, is that the green right there?
Yeah, that's right out front of this building. There, right?
Fantastic.
Got it? Yeah.
Okay.
That's not green.
No worries. It's okay. We're going to build a structure right in the middle of the green, which will upset some people. Okay, and great, we'll say that's fine. Let me import this image. Okay. Now, as we're starting to build this structure, I'm not going to think very detailed about what it is, but I can start by just describing kind of just sort of a general mass shape. I have some idea of what I want. It's going to have some sort of size, a width, a length, something like that. Okay. Let me go through and extrude something up here. Okay. And I can click on these different things, and I will give that a height. It's going to be 30 feet tall by whatever it is, like 60 feet in this direction. Oops, looks like that was 6. Okay. And we're in pretty good shape there. Okay, that's enough to kind of get ourselves started in terms of what's going on. Maybe this building is going to have a slightly different shape. I decided that, maybe it'd be nice to have it like slope down this way because I want it to be a little self-shading. I can really get very, very elaborate in this kind of form making. I won't do it now, just in the interest of time, but you can go through and create just really kind of interesting shapes. And, for example, if this building's going to have like an extension off to the side, let me just show you that. I'll just kind of do some sketching. In a lot of ways, this is like SketchUp. That's what I like to sort of compare it to. This kind of mass modeling. I can take that thing and pull it on out, and okay. Whatever. That's a good space for a solar collector or something like that. But I got some basic shape hanging around in here. Beautiful. Let me go ahead and finish that up. I can start to understand that building in a lot of different ways. One thing I can do is just to start to understand, the solar radiation and how it's hitting those surfaces, and really what's going to collect a lot, what's not going to collect so much. And there's a tool that's built into here. It's a subset of what's available in Ecotect. Ecotect is kind of the granddaddy of these tools for doing this kind of analysis. I'm going to go ahead and just use a subset of it here to just do the solar radiation, where what I can do is just choose the different surfaces I'm interested in seeing. And I'm kind of interested in, let me see if I can find something in here. I want to know about that front face here, maybe that side face there, maybe even that face at the top there. It's often good not to sort of get the primary roofs, because roofs tend to get so much sun on them that it almost skews the entire scale of what you're looking at, so you don't see meaningful differences in the sides. So I'm going to get that face over here too. So I have these different things. When I go through and close the selection, it'll go off and start analyzing. Okay, and what that's basically telling us there is that of these different surfaces, here's how things are sort of stacking out in terms of the sun. And this is the cumulative radiation right on the spring equinox. We can look at this a lot of different ways. We can see that this surface is actually getting the most sun. That probably would be a pretty good solar collector. Not very much sun at all on this side. That's because this side over here is actually, I think, the east side in terms of what's going on. On this side, we're getting some sun, not as bad over there. That's probably because of the way we're shading it towards the front. Okay, now this is at the spring equinox, so that's that one day. If you want to start to understand the building in a little more detail, though, we can say, I'm not just interested in that one day. I really want to understand across the entire year or the entire season, what's happening here. So I can say, as opposed to doing it just for the single day, let me just kind of see how it works throughout the entire winter from, December through March, or maybe we can even start our winter a little bit earlier. Let's say just the whole cold season starting back in October. We'll say OK. Okay, you'll see it's a little bit different now in terms of what's going on. The scaling's changed a little bit. What's happening is that I start to consider just the changes throughout the year. Okay, it's a little more gradated. Again, this is cumulative. I can look at this as a point time, or I can look at the total amount of energy we're collecting over time. Either way, but solar radiation is something you can start looking at just pretty quickly within Vasari. Okay, so another thing that you can start looking at very quickly within Vasari is, let's look at energy modeling. Actually, let me go back into the model and do one other thing to it. In order to do energy modeling, we have to understand our model a little bit differently in that it's not just a big block. We like to think about the model actually having different floor levels to it. So let me break it up into different floor levels. Okay. At a very high level, you could look at the building this way. What it's done is it's sort of said, hey, given those floor levels and this size of the building, yeah, if we started saying that there was a certain percentage of glazing to solid surface on each of those different building surfaces, yeah, this is what the building might look like. And at a really high level, we're doing it in 10 minutes way. This is probably okay for the type of analysis we're going to do to compare alternatives. Okay, you can always go through and adjust these things though. If your building is such that you want to say, oh, for my building, I'm really picturing more glazing or less glazing. Well, let me put in like a 30% glazing. I can put that in there, and it'll sort of shrink all the windows down. Oops. Let me change that back to, like 20% again. It'll shrink it down. Now, if you want to actually go ahead and have some customization, though, and often you do, let me put that back to the 45 where we started. Okay. You can say that, I do want to go ahead and have some special features in here. I don't want to just sort of have everything be completely uniform. You can say that, well, maybe for like, this surface over here, and let me go ahead and choose that specific surface. I have to tab around a little bit to get to it. I got that face. Maybe for that face, as opposed to using the overall percentage, I want to put in a custom percentage there. So I can say that, for this one surface here, as opposed to being 45%, this one I want to have 80% glazed. And I'm going to put a shade on this surface that's going to be, 5 feet out to kind of provide some shading. So I'll get kind of a lot of view of what's going on in the green, but I'll also have some sun shading to hopefully keep the sun from making that room too hot. Hopefully it'll warm it during the time that we do want it there. So we can start adjusting things and adapting these things. But at a high level, what Vasari is good for is doing this. And you can create several alternatives and compare them, but I'll do it for this one. I'll analyze this model. What it's going to do is basically package this model up and send it out to, there's basically a web service, okay, that's operating in the cloud. And I'll say this is my NGIT option 1. It's going to go off to the cloud and start doing a little bit of analysis. Let me go ahead and let it do its thing. When we go out and when it gets done, it'll actually show us some stuff. Let me see if I can find it in here. It's probably still working on it.
So you set up an account?
Yes, and what it is it's basically your Autodesk student account. So the same one that you download your software from, it's the same account. It basically gives you access to the web service for doing this. And in terms of what it's doing, it's actually it's the same model that Green Building Studio, another product that Autodesk puts out, uses. It ultimately all uses the DOE 2.2 model for doing this analysis. But the idea is, can I go ahead and put this together in such a form that you can just use it like in 5 or 10 minutes, as opposed to doing a very detailed model and kind of putting it all together. So here we are, we're hanging around here. It's almost done at 96%.
Could we also download this program, or is it just
Oh,
on
yes.
the web?
Yeah, no, well, actually, I take that back. The program you download and you put it on your machine, but the web service, the part that actually does the calculations,
Okay, it's on the
it
web.
needs access to the web to do that. And why it does that is partly because now I could actually do 5 or 6 different analyses and run them simultaneously. Well, that's interesting.
Click on, I don't know, open the internet browser.
Yeah, you think I dropped off? I thought I was. No worries. Let me go ahead.
But
No, let me go ahead and I'll just go ahead and like show you another analysis so you can sort of get an idea. Just because it's yeah, in the interest of time, because I'm going to have to leave in just a few minutes, we'll go ahead and like just show you kind of what the results are, even if it's not for this groovy building. Yeah, there's just something going on that's a little bit off. For example, I did this thing over here. Actually, let me look at the whole notion of, I often do this little building where I sort of say, hey, what's the difference between having a building that's kind of very low and flat, that's south facing? You know, what happens if it's kind of tall and skinny? What if it's very cubic in form? That's kind of a really interesting thing to look at. For the same amount of space, what's the most efficient way, energy-wise, to actually sort of encompass the same amount of volume and create the same amount of floor area? So if I want to look at something like that, let me grab these, and I'll do a little comparison. This is sort of what comes out of this at the tail end, is you get this little report that shows you really for each of the different building shapes, really what is the total projected energy use over the life of the building. Now, this number, like, pay no attention to this number because really the odds that it's actually going to be that number over the next 3 years, it's like nil. It's not going to be that number. But this is very good as a comparative measure because given the same set of assumptions about how many people are coming in and out of the building and how they're using the building and what's going to happen to the energy prices, comparatively you'll get the right result even if it's not absolute. So this funny shape, the little cubic shape, has an energy use intensity, and that's a good way of kind of thinking about things as an energy use intensity. That's just how much energy you're using per square foot, so it normalizes things. 64 kilobtu for this cubic building. If I switched over to kind of this more flattened out building, it's about 59 kilobtu. The tall, skinny building, 78 kilobtu. So there actually is a very significant impact you can have by just how you shape the building in terms of how much energy it's going to use. Now, intuitively what's going on here, if you think about the amount of surface area that's exposed to the elements for that building versus some of the other ones, that has a lot of exposed surface for the same amount of volume that's encompassed. So that's why it does very poorly. It's exposed to the wind, the cold, and the heat an awful lot. If you think about the math, cubic buildings, or buildings that are even spherical, or like, would do better in the scheme of things because you're encompassing an awful lot of volume with the minimum amount of surface area. So these types of buildings tend to generally do a little bit better. But a funny thing happens that sort of biases the equation a little bit in that in terms of surface areas, things that are exposed to the roof and the walls are more problematic. The ground is actually considered to be a very favorable surface because it almost always has a temperature which is pretty close to what you actually want as a desirable, like a room temperature in the building. So what'll always happen out of these things is it'll somehow be a race between a very efficient shape and something that hugs the ground. So ground-hugging buildings tend to do well in terms of just their energy use because it's like a big thermal insulator and a big thermal storage system. It's really good to kind of be up against the ground. But sorry, lets you kind of get at these things pretty quickly, and that's kind of the gist of what we.
I think also something to do with the wind, because if you go higher, you have more wind.
Oh, exactly, and that would actually have a cooling effect up there. Now, the final piece, we'll go ahead and show you this, because the big main uses of this is really, people do this for very quick mass modeling, to do energy, and to do solar analysis, things like that. I could actually, I won't show you today, but I could actually refer you to, or when we come back, we'll show you, there's a tool where you can do the same sort of conceptual massing and very quickly generate a structural system out of it, so that, again, for 5 minutes, let's put some beams and columns in there and actually get something that we can start analyzing.
Is there a web tutorial system that's in place for this type of stuff?
Yes, there's a whole lot of stuff that's on there, and I'll show you where some of that is. It's, for getting to that, if you get to...
I teach Ecotech in Building Systems 4.
Mm-hmm.
And I was interested in this one because I haven't used this one.
No, it's actually, it's a really good one. It's really opened up the door to really all sorts of stuff. Yeah, so there's a couple things I want to show in terms of help. you know, Vasari itself has a fantastic help system, and there's a whole site dedicated to help for that. There is, for you guys, there's a whole curriculum of materials that are put out here. This is something I actually created based on my Stanford classes with the students. I worked with a bunch of students over the summer, and we did this, where we sort of packaged up a lot of learning about BIM and how to do things in BIM. So
That's
in
the
here,
website, bimcurriculum.autodesk.com.
Yes. yes. And it's just full of examples and videos and tutorials that show you how to do some of this stuff. So for example, a lot of what we were doing today, you'll find down in, like modeling structural elements. You know, there's a whole series on there about putting in beams and columns and things like that. For things like the green building design, there's things like daylighting, power use, water use, just how to orient buildings for passive solar design. The Unit 3 we did before Vasari was available. If you come to Unit 6, Performance-Based Conceptual Design, that features Vasari. So that's a good series. It walks through sort of setting up a university campus and trying to decide on the shape of the
I
buildings.
suppose we need a pass to set up an account to get.
Well, actually, this one you don't.
You don't?
This one's actually completely free in terms of what you want.
But if you look at the last one, lesson 2, which program would that be?
This one, parametric modeling. Okay, that's going to be within Vasari. Okay, and then, excuse me, pop back out there. Actually, here is lesson 2. That's further down there. Hang on. I'm going to pop down to, let me just go to any of them. Unit 7 is a lot of things about construction. So within construction, you'll find things like, let me find it in here on this side. Modeling for construction. This is a lesson all about, it's really just how we go through and like basically do things for steel frame buildings versus concrete frame buildings and like, adjust the structure for that. Each of these things basically has a little video. I'm not going to do it now. I have to install Silverlight today. But it has a video that you play. All these videos are actually on YouTube also. So, there's a bunch of stuff out there for you. Okay, so that's a good place. Again, there's a lot of help and resources for doing some of this stuff. So BIM curriculum's a great place to be. If you're really interested in sustainability issues, though, let me show you another one that's actually sort of a very good place to be. Sustainability workshop at Autodesk. So less on the structural and the building side, but this is full of a lot of things about Vasari and also just more high-level strategies, Ecotect, and just a strategy used that you then test in the tools as opposed to being more tool-specific.
Are these all linked through the Autodesk Education Community main
Yes.
website? Or
Yeah, even if you go there, go looking around for, it says like tutorials or help or learning resources or something like that. And it will point you to a bunch of these. And again, it's just a bunch of stuff that's out there and available to you kind of work with. Okay, so let me go back over to Vasari for just a second. We'll finish up there with that one last little piece there. And that is, the missing piece we haven't shown yet, which is wind. And, let me just go through and create a couple more pieces here. So I'm going to do something else like this. I'll create another building over here. I'm just littering buildings all over your campus. Someone's going to be very upset with me.
So you use the web resource because of the processing power needed to do all this? It's beyond the personal.
It's partly the processing, but yeah, you could actually do this on your own machine. It's really more by collecting.
So is there a toggle that you can tell it to process on the machine?
No, if you want to process locally, then you'd use Ecotect, the other tool. That's all locally based. The nice thing about being out on the web, and they're trying to move a lot of stuff, is that there is that, the climate profiles and the utility data. There's some stuff that's nice to sort of centrally maintain. Okay, and by putting it out there, they can actually kind of give you live data as opposed to just kind of a canned set of it. So, it is kind of nice. It keeps on getting better because it's based. Like the report keeps on changing a little bit. Let me show you in here. There's this whole thing about the wind tunnel. This is all about, if you're interested in doing wind analysis, there's a wind rose over here. And the wind data in the rows over there actually is accurate for Newark. So we can do things like say, really, what's happening to the wind speed as we move around and change the wind intensity in different directions. And you can start to see sort of really what the effect of the wind around your various buildings is. See where you start having shedding problems or vortex problems. where you have dead spaces. If you're trying to plan some sort of naturally ventilated thing, figure out where you're blocking the wind.
That's cool.
So
What algorithm does it use?
that I don't know. That I don't know. It's all somehow it's based on computational fluid dynamics, but I'm not sure whether it's fluid. Yeah, there's all these different tools. Yeah, I'm not sure which one it's actually using for that.
Can you export snapshots of this?
Yeah, we could do. That's a good question. There's got to be some way to do a screen capture in here. I know we can even get a movie out of here if we try. That's just how that's displaying.
Print it to PDF, right?
Yeah. That's sort of a good question in terms of that. I'd have to think about where that is. The worst thing I do is I do snap it or I do something like that just to grab us. Yeah, but I don't know right offhand. So you can do it either this way. This is kind of a nice way to do it. Let me show you one other way you can do it, which is if you, instead of looking at these 2D planes, and again, I could look down at the ground or I could look up near the top of the building, whatever it is that you want to do there. Let me go ahead and stop that simulation. Let me turn off 2D, and what I'm going to do is actually create a 3D simulation. Let me say show the 3D data. In terms of what's going on here, let me not show it as a point cloud. I'll show it as something called flow lines. And then let me see if I can restart it again. Okay. Takes a little bit, just a minute to kind of like set this up. But this will actually start showing you, as opposed to just the big color graph in 2D. Oh, come on, data. Do your thing. Oh, you know, my wind rose is pointing in a funny direction, is what the issue is right now.
Flow lines, maybe lines, yeah, they're like actual particles.
Yeah, let me see if I can get this thing shifted around for you. Not that. There we go. I need to shift my wind. What is going on with you? I'm looking at that. Let me try changing to another kind of a surface. It's kind of weird about why it's going out there. Oh, there we go. I knew we'd get to them eventually. Okay, it took a little while to generate it. We can go ahead and let me kind of cut down on the number of lines a little bit. I'll slow them down a little bit. This is all just graphical to make it look a little bit better to sort of see what's going on.
I didn't notice that wind tunnel was in Ecotech.
That got added in version, I think it was 2.1, and now there's actually a...
Turn on like line in there?
Yeah, all that you can sort of, in terms of, you know, how long they should persist. Yeah, so we can start to, yeah, just really get that to be whatever you want to in terms of understanding that. Okay, but you know, within this tool like this, you can, it's like those diagrams.
That can totally replace the real wind tunnel.
It's pretty darn close in terms of what's understanding, and then you have like a, you know, and this is really just the beginning. If you really want to get into this, there's another tool called Simulation CFD, which goes, you know, one step further. This is good sort of very high-level analysis in terms of understanding what's going on. This isn't so good if you're looking at a single building and you want us to understand a thermal chimney or just the ventilation just in a smaller space. Like, this is too coarse a level to be doing that. Okay, but
Can it show you like force loads?
say again?
Can it show you like will it calculate the loads exerted by the wind?
No, that it doesn't do. That would actually have to go back into like one of the analysis packages.
There must be maybe, I don't know, I'm wondering, like when we do that in real life in the lab, we have like pressure coefficients with pressure gauges that measure wind coefficient.
Sure, as it's going past different surfaces, yeah.
Does it do anything close to that?
I don't know of a way to do that in that. You know, so I could find out in terms of doing that. But I think that my suspicion is that this as being the very high level one, you know, it doesn't have it in it yet, but it'll be one of those things where you start seeing, you know, more and more development. Because, well, you know, I think one of the big things you're starting.
This is really fantastic. If they develop it a little further, it can do so much.
Oh, exactly. And I think just really, as you think about where Autodesk is going, that's a good way, Donald, for us to finish. It's this whole thing about, you know, in the past we've been very much, you know, a lot of what AutoCAD did at first was really, it was modeling in service of like drawing production. It was all about producing documents and things like that. It was a sort of efficiency thing. Then, you know, with all the building information modeling, we've gotten much more into how you can use the building models to actually support the entire process in terms of the constructors, and the engineers being able to use that. But I think you're seeing a very big push right now towards using the power of what's available in the cloud and in the web to like bring analysis tools to your desktop so that you as a designer get a lot more feedback about what you're doing, about the energy performance, about the wind performance, about, what is the life cycle cost of the materials that you're using. There's a lot of stuff we'd like to sort of give you some feedback on, so as you make your design decisions, you actually have a little bit of feedback to help guide you about what the impacts are going to be.
They're even trying to link it to alarm systems and things like that.
Yes. Oh no. Ultimately, the whole big push now to say that not only is this sort of a model for the purpose of design, but the model can then actually be used to actually help operate the building, where we could censor and really control what's going on in the building, based on the design intent that we encoded in the model. And the idea of having live buildings, so that as opposed to sort of designing on worst case assumptions or average assumptions, but to really be able to censor what's going on, with the actual number of people in the building and what's going on here, to dynamically control the building as opposed to have a prescribed schedule, it's very powerful. Yes?
Is there a continuous slide?
Which would be to?
Because there are intervals.
Oh!
What other options in the display, like is there flow lines?
I don't know. Let's just go and take a look. In terms of, that's flow lines. The big ones that are sort of within here are, it's really more like point cloud and ISO surfaces, things like that. But it's
consideration buildings in the area.
Oh, in this case, it's only considering the buildings that we sort of dropped in here. What we would do, if we were good about this and we were really going to go through and do our analysis, is all these other buildings, we would go back over here and we do things like create masses.
You have the model on, right?
Yeah, just go through and trace them at some level.
Well, because it's tied into the Google system, is there a way to use their 3D warehouse?
Actually, as far as I know, it doesn't. You'd like it to, just for the mass models.
Well, not only for that, because that also has a topography feature where you can
Oh, sure.
the site model.
Yeah. At this point, it's not connected that way. That'd be a really good idea. Because really at some point, we're kind of crowdsourcing a 3D model of a world. Yeah. So, but as far as I know, there's not a connection like that yet. Okay. It's a good idea, though. That actually would be great to be able to pull that data in. Okay. So we're going to have to wrap for today. Hopefully that was helpful for you. For some of these things, I know we have some things about line weights and even bringing things in from Rhino. Oh, let me give you the contact information so you can go from there, because really, this is really just the start in terms of, as you have questions and need help with stuff, I'm really here to kind of answer questions for you, so hopefully it's got us started. But really, there we go. Here's the way to get a hold of me, and you're welcome to contact me at any time. I actually just respond to email all day long. Let's say it's glenn.katz, okay, and then autodesk.com. Hopefully that'll be easy. Okay, so send things to us, and it's one of those things, if I can't get the answer for you, or actually if I don't know the answer, I can typically find someone who does know the answer and kind of link you into whatever you need. So go ahead and take advantage of that. Okay. Oh, and if you want, if you're really, really stuck, you can call, and I'll do my best to answer things. So, got reviews tomorrow. You're really stuck with something, and you need to get something out. You're welcome to call. I'll do my best to try and keep up with stuff. Right. But you do have a first line of defense on the campus. Your student experts, who I'm going to go meet with now, and take advantage of them, because as a local resources, they're very in touch with what you need, and they have a lot of things. They can probably get you answers quicker sometimes in terms of what's going on. Oh,
Do you have anybody other than Ian Siegel?
there's like 5 of them all together, but they're in different areas. I'll find out more about who's there.
MJT?
Yes.
5 at MJT?
Yes.
We have 2 in the School of Architecture.
Another random place I'll let you know about that's just sort of a good place for you to know about is something called BIMtopia. BIMtopia is just actually my little blog site, and what I post out there is actually all these things. Anything I record and put together. In fact, let me stop the recording, as I remember that.